Happy New Year to all of you. Welcome to the first uHoo webinar in 2022. I hope you had a good start to the new year. I realized today when I was putting on my usual green shirt that I think I need to go on a diet because I can hardly squeeze it together. So the days between Christmas and New Year, I packed on a couple of kilos. So that's a delayed New Year resolution now. I have to lose some weight. But the other main thing that changed with me, and I don't want to make you jealous now, I just want to give you some inspiration. Actually, my background picture is the real view of where I have my office in the home now. So this is the Philippines, beautiful environment, beautiful countryside, and maybe an inspiration. Let's reconnect with nature. Let's take some time out and actually with our families, as much as it's feasible, especially if we are in the inner city environment, to connect with nature. Sometimes the pandemic has deprived us from doing that, and that's why we changed as well our location. So that's one of the inspirations as well for the new year. And it's nicely connected with our overall topic, right? We want excellent air quality. Now, in an outdoor environment like this, you get a bit of open burning occasionally in the neighborhood. That's normal here in the Philippines, even though it's illegal, but lack of enforcement means it's happening quite often. But other than that, we have pristine environment. Our topic today is really unlocking the potential of Proptech in optimizing indoor air quality and occupancy management in a world reshaped by the pandemic. So really, we are looking at indoor. That's where we spend most of our time nowadays, nearly all of our time. And most of you guys are as well from home. Some are still, working in the office or back to the office. It really depends on the circumstances. We have two excellent speakers today that are with us. We have Nick Schulman, the CEO and founder of BlockDocs, all the way from the UK. They are focused on IoT, data analytics, and linking it with smart buildings, occupancy, and public transportation. And then we have Steve McLeod, all the way from the US. He's the CEO of Indoor Environmental Systems. He works a lot with businesses, factories, and he has a fascinating case study as well to share with us later on. So I'm really looking forward to this, but we will kick it off with a poll at the beginning, where we want to know a little bit from you guys. What are your thoughts on this topic, on the topic of Proptech, IAQ, data management, and so on and so on? Let me pull up our first intro poll here. And the question is, you should see it coming up on the screen now. What is the most crucial impact of Proptech for you and your business? It's a multiple choice. You can basically click on several answers. Is it efficient operational and business processes? Is that what is in it for you and what's your experience? Does it mean for you effective client interaction? Is that your desired impact? Increased energy savings, improved employee health, enhanced transparency, or maybe you think it has a negative impact or it's made no difference. So you can really answer whatever you want and go ahead with it. I see we have both the polls here on one screen. That means as well the second question is being asked at the same time. What do you feel would limit you from adopting Proptech technology? There we have as well a couple of multiple choice answers. So feel free to answer both questions. I will wait till at least 60 or 70% of our audience has answered the question. So really eager to see what you guys are perceiving as the crucial impacts and expectations that you have from Proptech, and at the same time, what are the barriers to really make this happen on a significant scale? So I think we're getting pretty close to 70% of you guys having answered it. So let me reveal the results, and that will give us some good pointers for what is actually the feeling of our audience. when it comes to what's the most crucial impact that you expect from your business, we have 90% of those who answered efficient operation and business processes. Then we have 50% improved employee health, and we have 40% efficient client interaction and increased energy savings. And then 30%, maybe a little bit surprising to me, fairly low enhanced transparency. Nobody expects it to not make a difference or have a negative impact. And then we will look at the barriers. What would you feel could limit you from adopting Proptech? We have budget, 50% of people, lack of knowledge and expertise, 40% of people. I mean, that's one of the reasons why we're running these webinars, because we want to increase awareness and inform people what can be done out there. Then the business type and lack of engagement between the people involved as well is one of the reasons that a very low percentage, only 10% of people actually mention. So those are some pretty interesting results. Budget is often the main barrier, and maybe our speakers can help us with that today, because always we want to look at ROI, right? What's the ROI from the things that we do? So without further ado, I would hand over to Nick from BlockDocs. He will really focus on data, IAQ data, occupancy insights. I think that's a fascinating subject, and I'm looking forward to your sharing and your examples. Nick, over to you.
Thank you very much, and welcome everybody. I'm going to speak to you today about optimizing indoor air quality with occupancy insights. So just to begin with a short introduction as to who BlockDocs are, we're a Proptech focused data insights platform based in London in the United Kingdom, although we work globally. And we help organizations solve complex problems in the urban environment using artificial intelligence and the Internet of Things. So not assuming any knowledge at the outset of the presentation, I think it's important to begin by highlighting some of the key indoor air quality metrics which people need to be aware of. And I've selected 5, all of which can be measured by uHoo, of course. So these are temperature, humidity, CO2, PM2.5, and TVOCs, which stands for total volatile organic compounds. And each of these metrics has an important role to play in indoor air quality. And the reason why indoor air quality is important is because we actually spend 90% of our time indoors, where the air actually gets trapped inside. And so actually indoor air quality is arguably more dangerous than outdoor air quality, even though a lot of the focus sometimes is on how polluted our outdoor environments are. And the usual method for mitigating poor indoor air quality is obviously increasing airflow, such as by opening a window, but in a lot of workplaces that simply isn't possible. So just to emphasize some of these particles that we're looking at, what we have here is on the right hand side, this is actually a human hair, and this is a grain of sand. So when we're talking about PM 2.5, which stands for particulate matter 2.5, this is where you'll find it in terms of size. It's essentially a dust particle. So it's smaller than a respiratory droplet. It's smaller than a red blood cell. And what that means is that it can enter your body, it can go into your heart and lungs. And unlike larger dust particles, which we call PM10, which are this size, which you would just cough out if you inhaled them, these dust particles can't be coughed away so easily. And of similar relevance is the coronavirus. So here we have the coronavirus. And the reason why it's important to measure PM 2.5 indoors is because the coronavirus sometimes hitches a lift on these types of larger particles, such as PM 2.5, as a way to enter your body. So the more PM 2.5 dust particles there are in the atmosphere, the more, let's say, taxi rides are available for the coronavirus to spread, and therefore it could be an indication of how unhealthy the indoor environment is and the potential increased risk of transmission in such a space. So looking at managing air quality in buildings, what we've seen since the pandemic is that indoor air quality has really risen to prominence, and people are much more aware of indoor air quality and its impacts, even if the detail behind is still somewhat unclear. And this has now trickled down into workplaces and other environments where essentially staff and visitors, whether these are commercial buildings or retail or so on, they want reassurance that the buildings that they are visiting to work, to shop, to play, are actually healthy. And now we've been exposed to the pandemic for a couple of years, and certain countries are expressing that we need to learn to live with COVID and relaxing rules. Certainly, that's the case in the UK. What does this actually mean? Because it doesn't mean that COVID has gone away, and it doesn't mean that similar respiratory viruses won't come along, in future, as we've seen in the past, for example, with SARS. So the need for indoor air quality management will persist, and in terms of learning to live with COVID, we need to have ways to manage those spaces. And then finally, the built environment is essentially the gas guzzlers of the real estate world. They contribute approximately 40% of carbon emissions, and a major contributor to climate change. So when you have to use a lot of artificial means to manage air quality, this obviously has a major energy consequence to it as well. So in terms of reassuring staff and visitors, this could be through a simple dashboard display, just letting people know that the spaces that they are visiting and working in have good air quality. So why should indoor air quality and occupancy data actually be part of this strategy? Well, improved indoor air quality is obviously a key indicator for the health of the space, and also the health of the people that are using those spaces. And therefore, the healthier the indoor air quality means there's probably less risk of infection. So aside from PM 2.5, as I mentioned earlier, parameters such as temperature and humidity and CO2 are also good indicators if they are showing elevated levels of the type of environment where viruses like to thrive. And that's not just for coronaviruses, but other viruses which can be spread through the air, such as norovirus or even influenza. And although those viruses may be less dangerous in terms of causing death or serious illness, they can be a major inconvenience for workplaces because they can lead to staff absences. And if you have a lot of people off sick, obviously that can impact productivity. So that's where occupancy data adds a new dimension, because when you start to combine your indoor air quality with occupancy data, all of a sudden that begins to allow interventions to be proportional and targeted to areas where people actually are or will be. And And because of the huge energy cost in cleaning air, that's really, really important because it has a major impact on energy savings. Due to the pandemic, many buildings have been following industry guidelines and essentially running their systems 24/7. And these systems were not necessarily designed to be run at that intensity for that amount of time for so long. Now a lot of energy bills are being scrutinized because they're much more expensive than anticipated. So you have to balance being able to clean the air with obviously, the actual air quality itself. And if you can target it away from places which are either unused or underutilized, then that's obviously a benefit. And finally, aside from the health benefits, it also improves productivity within spaces because the more healthy people are, the more focused they can be on their work, the less sick days they take. That obviously improves productivity. So at BlockDocs, we've been specializing in enhancing indoor air quality with occupancy data. And we've created our own novel and bespoke metrics, for example, around people hours of exposure to harmful indoor air quality. This is just an example of where we were looking into a building where it had recently been retrofitted and there were elevated levels of formaldehyde. So how this data could be used is either to introduce more, let's say, aggressive ways of mitigating the elevated levels of formaldehyde, which comes from off-gassing of new carpets and furniture and paint and so on, or it can delay the reoccupation of spaces until safer levels are observed. And that could obviously be built into the timescale of a retrofit. Or if it's important for people to reoccupy the space, then the amount of time that they're being exposed should be monitored, because there are international guidelines around this, and there is a level of tolerance which can be monitored. In a similar way, therefore, through BlockDocs, we can blend the actual utilization of spaces with the indoor air quality insights in order to make this really relevant and useful for facilities management. And here you can see some examples of that. It can also be summarized in a back office set of dashboard displays, so that you can compare your actual utilization of spaces to how good the air quality is. And this means that at a glance, you can really hone in on those spaces where there may be either higher space utilization and poorer air quality, or vice versa. And that enables you to target your interventions according to those spaces which need most attention first. For those not familiar with occupancy data, essentially what this involves is using IoT, Internet of Things sensors, in order to count people within a space in real time. Here's an example from a location where BlockDocs was installed, where you can see that over a period of time, the line here shows people arriving in the space, and the space in question had a limited capacity. So the line actually glows a different color, from going from green to yellow as the space is becoming more crowded. And then we can observe in real time as people are departing and the occupancy decreases. So this is an example of an occupancy measurement on itself, and that means that you have a historical record that you can also go back to identify times in which spaces were busier. Where it gets interesting, of course, is when you begin to overlay that with air quality data. So in this example, which is focused actually on CO2 levels, what we can clearly see on the same period as the occupancy graph I showed before is that it follows the amount of people that are arriving and departing in that space. You might expect that because there'll be more people there and more people breathing and so on. But where it's useful from a building management, facilities management point of view is that you can then adjust your HVAC settings to compensate for the amount of people that are there, and then you can mirror that with increased airflow in order to maintain healthy levels of CO2 so that they don't exceed the targeted levels that you want to achieve. Here's a case study of a building where we were able to identify energy savings in excess of £1 million a year and annual carbon savings of just under 2,000 tons of CO2 a year, in addition to improved space utilization measures of at least £183,000. And this was from being able to show this building that essentially they were providing services to spaces which were either unused or underutilized. For example, 24% of the overall energy consumption was actually being incurred outside working hours between 7 p.m. and 5 a.m. when nobody was there. So there is quite compelling evidence now to show that understanding your occupancy and air quality data can make a real difference to the way buildings are managed. And so, what we do is we really enhance data that is available from occupancy sensors and air quality sensors to provide a very comprehensive way of managing those spaces efficiently, and also pushing that information out to our end users in terms of email alerts and through our API. So I will pause there and thank you very much for listening, and I'll be available to take questions after the next case study.
Great, thanks a lot, Nick.
Thank you.
I loved your example of showing us the size of the gigantic hair, the minuscule COVID nasty, and how it can hitch a ride, taxi ride on the PM 2.5. Now, one quick question for you. Really, the work that you do is on the connection between the data and the actionable visualization and information provision from the data. One of the questions we had that came in advance was how data can influence change. You have a quick comment on that, how we can optimize that ability of data to generate change, before I pass to Steve.
Sure.
Yeah.
Well, I mean, in terms of, I guess a quick answer to that is obviously you can't mitigate what you don't measure. So if you don't know where the problems are, then you can't take action in order to improve those spaces. So data is really important in that respect, and blending different types of data which are not normally seen in context together is actually really invaluable.
Yeah. I think that's crucial. The blending it together, making it digestible, like presenting it like a cooking on a nice plate, where the end user gets so hooked up and excited about it that he wants to dive straight in and take action. And I think that's a good link over to Steve's presentation, because Steve has a really exciting example of a lot of things are not in shape, but unless you have the data and you let the data speak the language of knowledge, you might not be knowing where the problems are. So Steve, over to you. And by the way, just one more thing. Actually, Nick's background is his real office, but he's not there at the moment. And Steve's background is not the view out of his window, but the view from the tent when he used to camp there when he was a young guy. So I guess that's why you are into the, helping the planet, helping the people as well, close to nature. Excellent. Steve, over to you.
Thank you, Matthias. So yes, climate change is threatening this area in Yosemite that's in my background now that things are burning up in the Sierra Nevadas. So I feel that it's important to do all that we can to help this planet stabilize its climate. And some of the things Nick talked about on how the property tech is working to help identify some of these areas where we're spending more money than we need to. And so here I'll share my screen. And property technology, also known simply as Proptech, is defined in this context as technology and software usage to assist in building operations. And so this is a case study from a foam manufacturing plant in rural North Carolina. It's a good sized plant, and they manufacture these swimming pool foam products, which are a combination of unique chemicals. And the plant's been in operation for quite some time. And one event that occurred was that this freight car, or this truck, caught on fire when the driver went to the back of the truck, opened up the doors, and then lit a cigarette. And the reason this occurred is because this product has to off-gas its chemicals for at least 30 days in these large warehouses. And in this case, the shipment went out too soon, it built up in the truck, opened up the truck, kaboom. So the company hired a new individual for health and safety. And this individual comes in, and he was concerned when the heaters went on during this winter that it might blow up the warehouse. So through the grapevine, he got hold of me, and I wanted to work with him on this whole process of how the chemicals are being generated and why there's concentrations in the building. So in this picture, we're seeing an area where they mix the chemicals and they have these molds that press out the different item that they're trying to make. And because the chemical that has the largest odor, or the strongest odor, is heavier than air, they have designed their ventilation system to pick it off the floor and take it out. The trouble with this is that the ventilation systems are not strong enough to move out as much of the chemical that's being generated, especially here in the ovens. So here the product has to be cured in these ovens. However, since the source capture is not designed into the ovens to take out the chemicals actually cross-contaminate into the warehouse area. The fans are up on the top of the roof, and so it makes it more challenging to get a proper airflow to remove these odors. So when we started looking at it, I wanted to experience how the fans were working, and sure enough, only 10% of the fans were even operational. Nobody was really in charge of this ventilation system, and it's not automated. They're just living with the high amounts of chemicals that are in the air. So we started with, let's inventory exactly what we have. Let's see about the maintenance. Let's test the air exchange, and we can even follow the patterns of the gases with theatrical fog. And what we found is that there are fans on the ceilings, there are fans on the walls, there's entryways where fresh air is supposed to come in, creating these wind tunnels to help flush all this out. But it hasn't been maintained. Everybody was just going about their business. The only thing that they really knew about was when they walked through this door, that it would just massively blow your hair back because of the other penetrations on the walls that were obscured because they've been packing things like these cardboard boxes on it. So again, it's this lack of knowledge that has created an environment that is counterproductive to the health and safety of the occupants. So here we wanted to talk about removing the obstructions, getting the fans working, and then start data logging what's happening with these air quality parameters, such as temperature and humidity, CO2 and TVOCs. Interesting here that one of the other challenges is that the more fresh air that you bring in, especially during the AC season, it's going to be richer in relative humidity. So that temperature here in rural North Carolina is going to have more moisture and more heat during the summer. So that is causing a condensation issue to happen on some of the manufacturing. And with that condensation, now there's products that are being damaged. So there's an interesting balance that needs to occur with how much fresh air we can bring in to reduce our health and safety concerns, but also not affect productivity. Along the way, we see that the HVAC system has got some issues. This is mold growth occurring again because of condensation on the system. Now, this wasn't why we were called in, but this is an observation that is important because it relates, again, back to health, safety, and it shows us that there's lack of education on the side of HVAC because this should all be properly maintained. And since it hasn't been maintained, now we need to move into mold remediation. There had been some roof flooding and nobody had cleaned up the mess. The return ducts are clogged, they haven't been maintained. So with all of this, the HVAC system is not functioning properly. And then it's not drying the way it should. So again, we get condensation, we get confirmed mold growth. And then these systems are not coupled together. This is an older manufacturing plant. So here, the ventilation system, the HVAC system are just manually run. So we have the challenge of having all this be balanced in such a way that it's efficient so that we have a constant indoor air quality that is of good quality versus somebody doesn't feel good, somebody doesn't come into work, or there's a new individual there and they haven't really been properly trained on the equipment. So now that we had finished the visual inspection, I wanted to see what kind of chemicals were in the air. So this was a test where we pulled for 2 hours a sample, and it shows a severe level of TVOCs that were in the air during this time. And breaking down those chemicals, we see that 94% of them were coming from manufacturing. And then we can break it down a little bit further. And out of the 176 chemicals that we looked for, these were some of the ones that were highest. So this is good information for the company to have an understanding of, wow, there really could be a health concern here because of what we're generating. So next we brought in the Aura for the data logging. And so here we're looking at CO2 levels during this trend from the 4th to the 21st. And we see that the levels are all over the place. But when I look and I see that we're at 550 or 505 at a high, this to me indicates that our CO2 levels are fine and that they're not going to be a good indicator for the TVOCs. Typically, those two are high. And as I bring down the CO2, my TVOCs come down, which is common in an office environment, but why not in this environment? The reason being is that we only have a few employees, in this case 50, but they're in a huge warehouse. So I don't have a challenge with CO2 because we're just not generating enough to raise the levels. So this is not a good indicator of air quality for us. Whereas the TVOCs, we see that when production occurs, bam, there's a huge spike here. So after we had done the assessment and we changed all the belts. We got all the fans that were being obstructed clean and ready to work. Here we could see dramatic drop in our TVOCs. And then we go on to a weekend where there's no activity, and the individual involved in this new education process for ventilation forgot that he has this power to be able to ventilate. So sure enough, boom, it goes up, and then people start complaining again. And then the ventilation gets kicked on and we see it drop back down. So this is very beneficial to us because now management is able to see what was hidden before. With this data, they're able to graph it out and have some facts showing what's happening in this cause and effect realm. In regards to PM 2.5, we found that, like the CO2, it was all over the place. And our initial thought was that, well, when we're in high productivity, because of what they're doing with the products, we're going to increase our PM 2.5 levels. But what we found is that it didn't match the TVOC spikes. It didn't match production. So then we brought in the timeline for the employees' shift changes. And now we can start to correlate that, oh, a lot of these particles are being generated just by the movement of personnel. So then that moved us over to janitorial services. How well are they cleaning up the residue from the last shift? So again, the information that we're grabbing from the data logging is so important because it shows us these different areas where we can have an effect. In this case, janitorial, to help clean up the particle loads that are being generated. And then on the virus side, they were pretty high pretty much all the time. And the reason this is occurring when we look at these three parameters of temperature, humidity, and particulate is because it's cold, it's dry, and there's a lot of particulates for the virus compounds to hitch a ride on, similar to what Nick was pointing out. So here, the ventilation during the winter is not going to dramatically affect this because the outside air is cold and dry, and the PM 2.5 is not being reduced by increasing ventilation. So here, the one parameter that we can do the most work on is on the janitorial side. We can do better at filtering and cleaning. So to summarize, there were elevated levels and dramatic swings in the TVOCs and particles that are occurring due to ineffective ventilation procedures, non-functioning fans, and obscured ventilation pathways. The chemical testing of the ambient air and data logging with the Aura IAQ sensor has confirmed elevated risk and health and safety concerns with the TVOCs and the PM 2.5. So for improvements, we talked about monitoring the TVOC, the humidity, the particulate matter, and odors, as they are the data points and the variables for balancing and improving indoor air quality and the health and safety, as well as the productivity at this facility. Proptech, we feel, can assist in ventilation automation and greatly reduce employee operational challenges, making the manufacturing plant more efficient while improving the health and safety of employees. Additionally, reducing liability and perhaps employee turnover due to the reduced viral load and the respiratory distress that's currently happening. So I hope you found that interesting. Back to you, Matthias.
Yeah, thanks, Steve. That's a very fascinating case study. You know, sometimes it's difficult to get insight into examples of where things are not 100% in best shape. So thanks for sharing this. And obviously the TVOC problem is the biggie here for me. And I was kind of wondering, you know, wouldn't it be easiest, or I won't say easiest, wouldn't it be the best solution for them to try and look for alternative manufacturing methods and shift away from the aggressive solvent-based approach, or is it going to be more costly for them? I mean, otherwise, I would assume that would be the best way of getting rid of the massive health and safety risks, and as well customer-related and fire-related risks of the product.
You know, I think it's a great idea. And the challenge with it, as far as changing the ingredients that make these products, is that these are these new modern age products. This is a group of isocyanate family chemicals that we didn't even have 20 years ago. And so because of them, we're able to mix these chemicals and have these chemical reactions, making this bizarre piece of foam that is durable and can float. So for them to go and change into new chemicals is something for them to look at, especially on the cleaning side. But on the manufacturing, here, what we determine is they really need to have better source capture. So if you're going to use something that's really aggressive as far as being volatile, we need to grab it right now and get it out into the air, which follows up on, well, okay, so now we're putting it in the air, so now it goes down the road. So now it would be talking about how do we extract those chemicals from the air that we're exhausting. My point being is that it's really complex, and it's a challenge to pull all these components together, but at least we're at the point now where we're starting to identify them. Yeah,
I mean, the first priority is to minimize the risk for the employees who are directly exposed to it. And I think that is a significant long-term liability risk as well. But secondly, what is going to be the carbon footprint of those gigantic volumes of total VOCs being extracted into the outdoor air? I'm sure if we were to put a carbon tax onto that facility, maybe the facility would not be financially viable anymore if we turn those total VOCs into CO2 equivalent in terms of carbon footprint. But that's another discussion for another time, just an observation. But thanks for sharing that fascinating case study. We had a couple of questions that came in advance. I'll start off with them. And I think they are as well related to what we saw. One of them was a person was mentioning they get total VOC coming in through their HVAC system. So I think that the source of the total VOC is coming from the supposedly fresh air. How could they filter that one out? Any suggestion on that?
So filtering out the incoming air, I think, is a great idea, because we've got pollen, and then we have whatever else is in that air relative to where the fresh air intake is being taken from. So in some buildings, it's pulling it in right at the parking lot. There's your high VOCs. Other places, it may be pulling in from the roof, but when the roof gets hot, it may be pulling VOCs from the membrane that's on the roof. So it's common for us to filter the fresh air for particulates, particularly pollen, at about a MERV 8 filter. But as far as the chemical load goes, much more expensive. So that's a challenge. And wouldn't it be nice if the building next door wasn't making isocyanate family foams and pushing it into their building? The other is that TVOC, since it's referring to total, is that some of those may be microbial volatile organic compounds. And it's common, all too common, that within the HVAC system, and particularly downstream of the coil, is that there's excessive mold growth. So here's our mold happily dissolving the dust that's in the air and making volatile organic compounds out of it. And that may be a source coming out. And then lastly, is that they may be measuring in the ambient air in the place, but because the air is so diluted, they're not picking up elevated levels. And then you push it into the HVAC, you compress it, and now it looks on your meter that, wow, this is the source. So it could be the three sources, and ways to deal with that have to do with removing the source, bringing in binders such as different types of carbon, other elements to capture it. And now there's technology that is breaking these chemicals down into smaller components.
If I can add, just to add to that, I think this question also underlines the importance of measuring in indoor air quality, because you may be in a building where you're not responsible for, or in control of, or can even see the HVAC system, and so you're just reliant, and you assume that when you go into your office, that the air quality and the filter is doing its job. So it would only be by using, an air quality monitor such as the uHoo that you would be able to identify that maybe it's not, and take action accordingly, as Steve pointed out.
Yeah. We had as well a question coming in advance, which was all about the data management and alarm setting. What is your recommendation on that, Nick? I mean, with you having done a lot of work on, combining the IAQ, the occupancy, where does your customer get an alarm that he should take action?
So in our experience, the end user is given maximum flexibility for where to set these thresholds. They could, for example, be following international guidelines from an organization such as Reset, or others, such as Well or LEED or BREEAM, or they could have their own thresholds which they want to achieve themselves. So from our side, it's flexible. We don't prescribe what those thresholds should be, and so different end users may be using different thresholds. And then when those are breached, if what we call a violation, that can then be notified to the end user. So it's pushed out to them, so they don't have to necessarily worry about always checking in to see if everything's okay. It's the reverse. When something is wrong, they'll be notified.
Yeah. I think that is the beauty of such a system, and as well of you can kind of define, right, where you set your threshold level and when you get notified. We have a question in the Q&A section, and if any one of you has a question, please put it in the Q&A section. From Dedi Rashid, the third part of the question, and I come back to the 1 and 2, I might have to ask that to Albert, who is here on our panel as well, because he directly represents uHoo. The third question was, I understand in the UK there's a new policy with regards to COVID-19. Will it be applied? Will be applied? Is the indoor air quality monitoring still an issue in the UK? I mean, it's not so clear that the question. Surely indoor air quality monitoring will be a very big issue, but how does it relate to the new policy with regards to COVID-19? I guess that's my interpretation of the question.
So the new policy in the UK is more of a political economic policy rather than a healthcare policy. And if the government want to pretend that COVID-19 has gone away, then obviously I'm sure that many other countries will be able to persuade them they're mistaken. So the need for indoor air quality monitoring is still there. We're speaking with lots of organisations in different sectors, from healthcare to office spaces, where this is top of the agenda, and the new policy around, for example, mandating wearing of masks and isolation periods and so on, that doesn't affect people needing to manage their spaces. Essentially, what the UK government is doing is that as a government, they're kind of like stepping back, and they're letting people manage COVID themselves. And I think they're going to see how that goes. And if it's not effective, then the government will intervene again. But we have a very liberal prime minister at the moment who likes to give people a lot of freedom, and he's very much in favour of allowing, I guess, the market to decide for itself, and hopefully most people will be sensible around that.
Yeah, I mean, we see a lot of large, especially listed organizations, as part of the ESG, environment, social governance. They're putting employee health, wellness, and productivity at the center of their office-based organizational management, and hence it's going to be critical for them to monitor, evaluate, understand, and improve. Otherwise, they will lose a lot of money due to unproductivity, absenteeism, and so on and so on. So even though it might not be an absolute regulatory requirement, it makes a lot of business sense to have this on the radar screen. So with regards to the question from Deddy, I suggest question number one, which is related to the PM 2.5 and PM 10, showing similar levels. I guess this is a personal private question that maybe uHoo staff can get directly back to him. But question number two, when is the noise level sensor being initiated? Albert, is there any update on that?
Yes, there is any update. We're working now on the firmware of the uHoo Aura, and it will be probably available in, I think, this quarter anyway, but I think it will be February, but it will be activated. The sensor is built in, but we need to work on the firmware, and especially with sound, it is a very complicated one, because what are you measuring? Are you measuring the whole environment? So that's very complicated. So that
complicated, but it will provide some great insights for people in terms of what's going on. And then we have even more data.
Also, and also having the light also built in and the sound. So we are focusing on the entire environment of a building or a room, not only air quality, it's the total environment.
Yeah. One of the questions that came in advance was, how do we actually monitor and manage and compare multiple buildings at the same time? So someone who's sitting in an office somewhere, can he have like multiple dashboards or integrated dashboards? Maybe Nick, you can as well give a recommendation from your practical experience on that.
Yes, so that's obviously one of the use cases that when I founded BlockDocs, we set out to tackle, because a single facilities manager can't be present in all of the buildings that they manage at the same time, even if it was a single building and they were managing multiple floors. So it's obviously extremely useful to be able to have issues brought to you, rather than be worrying about what's going on in different buildings, particularly in international organizations where those buildings may be located in other countries. So yes, each building can have its own dashboard interface, but the data can also be pushed centrally, and there can be an aggregated overview across multiple buildings, and that also gives opportunity to benchmark similar buildings in different locations, and to check that approaches to managing indoor air quality and facilities management that work in one location are mirrored in another, and vice versa.
Yeah, I think that's a great suggestion as well at the end, the benchmarking. And that comes back to the earlier question, how can data influence change? If you benchmark the different locations and make it a little bit like a internal competition, who has the lowest carbon footprint per square meter, who has the healthiest indoor air, then you're seeing people coming competitive. Then middle management will put it on the radar screen. Maybe even you have a score sheet benchmarking them and stuff like that. Then you will see a lot of momentum going on. Steve, one question that came in advance from the audience was, how do we reduce high humidity? I think you mentioned that's a problem during the summer in the factory, and it's as well a problem here in Southeast Asia. We often have high humidity. The temperature might be okay, but a high humidity makes us feel very sweaty, and we need to, use more aircon than otherwise if we were to control the humidity better. What can we do about that?
Humidity is a challenge, and essentially what we're trying to do is either not put it in the air, or we've got to take it out of the air. And so here in America, we use air conditioning, and we're using the benefit of having a tight building so that we can control the amount of humid air coming in and dry it out. Swamp coolers are another common item that people use around the country. Essentially, it's a challenge to get that balance of how much air can I bring on in, but not too much air because I have to heat it, cool it, or dry it. And that's where the sensors come in. It's like we need to monitor this and do the best we can with dialing in that balance. In some cases, the TVOCs may require more ventilation than the comfort level for the occupants can handle with the humidity. So there's a little give and take, and we don't know what those levels are unless we measure them. And then being able to have that automated so that it balances it out is the most efficient way that I currently know of.
Yeah, great. I learned from a friend that some people were working on this paint that would help regulating humidity automatically without the need to consume external electricity. But I don't think it's become a commercially viable product yet. Otherwise, we would have hopefully been able to use it or see it in the marketplace. So hopefully some smart ideas will come up in the future.
If I might build on that there are atmospheric water generators. So you can now buy a device that's going to pull the humidity out of the air and purify it for your drinking water pleasure. So interesting, wouldn't it be something if we could combine those technologies so that we can actually use it on a large scale?
Yeah. Excellent. Okay, good. Now let me get into our speaker follow-up poll. We are coming towards the end of our session here, and you get the chance to actually request directly following up with any of the speakers here that you've seen in action today. If you want them to contact you, they will get the notification. So please click and press the button whom you would love to stay in touch with. I'm sure the two stars of the night, Steve and Nick, will have a couple of more inquiries than Albert and myself, who are the regular faces that people see nearly every month. So next month, by the way, we will focus on net zero, decarbonization. How can we make our buildings as little decarbonized as possible? And yes, I have the information here. We have quite a couple of inquiries for Steve, and as well something for Nick as expected. But Albert, you and me, we go home empty, but that's okay. So, oh no, we have someone as well who wants to talk to us. So that's excellent, great. And I think we are gonna watch a short video or have something else happen now. Is that correct? But first of all, a big applause to both speakers. Great contribution, great input, excellent case studies. I loved it today. I learned something new. And I think we will see the video now, right?
Poor indoor air quality affects health and productivity and increases the risk of coronavirus surviving and spreading in the air. With uHoo, take control and manage your indoor air quality to create a healthy workplace. uHoo measures and monitors all the important things in your air, including a virus index, so that you can improve your air quality. And with the uHoo dashboard, viewing and managing your air quality in all your locations is simple, easy, and convenient. Once you've set up your uHoo devices for all your locations and assigned users to the account, you're good to go. Get a quick overview of your buildings and locations' air quality conditions. Real-time minute-by-minute readings on all the important air quality factors. That's simple and easy to understand. See your historical data so you can see trends and valuable insights about your air quality over time. So you can promptly identify specific air quality issues and address them to make your spaces healthier and safer. View all of your air quality conditions wherever they may be located, per building and per floor. Create custom alerts based on your preferences and receive notifications on your phone or email so you can immediately take action. Reduce the risk of coronavirus spreading in the workplace with the uHoo Virus Index. Get all the data you need to manage your air quality without worrying about data security and information privacy. uHoo. Take control, ensure safety, improve health and well-being.
So yeah, thank you very much. And officially we are kind of finished at the hour. I think we had 2 other questions coming in the chat box. I'm happy to hang around for another 5-10 minutes. That's okay with me. How about you, Steve and Nick? You have to move on, or you're still okay for a little bit of more chit chat?
I can stay for a little bit longer.
Yeah,
5-10 minutes, yes.
All right, good. There's a question from Anton Gana, and he is basically asking your views on the air purifying technologies such as negative ion purifiers. What factors should people look at, and what's your view on it?
So I'll jump in. So I have found that there's some benefit with bipolar ionization, where you're pumping out both positive and negative ions. The idea is that you're increasing the surface potential of whatever it is floating around in the air, thus making it more attractive to a ground or to the opposite charge. So the idea is you pump a bunch of, say, negative ions into the air, the positively charged or the negatively charged dust is increased in its charge. So now it's easier for it to go to a ground, and then you could wipe it off, the ground being the floor or some surfaces. And in the laboratory, they work really dramatically. So you can get a compartment and fill it full of smoke and pump in ions, and you could see it all disappear. But when we take it out into the real world, there's not studies that are supporting how massively effective this is on removing particles, and there's different dynamics at different sizes. So I like the idea of increasing the negative ions, because if you look at Matthias's backyard, he probably has a 4-to-1 ratio of negative to positive. If you go to an area where there's water or by the ocean, nature is going to be generating a higher negative charge. And a lot of that is actually coming off the tips of your leaves. So the sharper the leaf, it acts more as an ion generator. So there's a physiological benefit to having an environment that's rich in negative ions. Works as an electrolyte, it helps our metabolism, it helps clean the air, helps us feel better. But as far as it being something that is worthwhile for you to spend your money on, I would look at the larger picture first. So what is it that I'm trying to accomplish, and what is the best product for that? It may be that I just need to turn my air purifier on high instead of having it on low, and I'm going to be filtering more air. So negative ions can be beneficial, but the return on investment is questionable relative to other technology.
How about your view, Nick?
I will defer to Steve on this with regard to ion purifiers. That's a little bit outside my scope.
Yeah, I've actually been a user of bipolar ionization since the pandemic began. And I've used uHoo to monitor the data. And I can only say that I've got pretty good convincing results in terms of low VOC and low PM 2.5 and a significant improvement. I can actually switch it on and switch it off. I don't have it here in my office, but I have it in the office of the other old place where I sometimes still go to as well. And so far, I've been pretty happy with it. But yeah, it's a question of evaluating what are the options out there. And if you can solve a problem at source by, changing your air supply, whatever else, there are many different things you should look at, and you should look at a holistic solution. But from an indoor perspective, I was quite happy with the results that I've been getting since I've used it.
Matthias, does it generate any ozone?
Yeah.
The one that I use is certified by, I think the famous US certification body. I can't remember the name. And I've actually not had any increased ozone levels either on my uHoo when I've switched it on. So the one that I've used, the brand has a certification that it doesn't generate ozone, and I've as well been able to verify that in my personal experience at home with the uHoo as a monitoring tool.
That's the challenge with this industry, is that the testing that I do doesn't confirm with the testing you've done or with the manufacturers. So it's really a challenge for the consumer to be able to know what's going to be best for them. And that's why I like these education sessions to really help us try and figure out what is best for us in our particular case.
Yeah, I think that gets backed up as well by Jerome Bove, who makes the comment. We have found that ozone emissions can vary tremendously by type and brand. Good to inform yourself or measure yourself. Yeah, either measure with the uHoo whether it increases ozone, or insist on the certification with regards to that it doesn't actually generate any additional ozone. I mean, there are some rogue manufacturers that just throw out some cheap products, and that could be problematic if it increases your ozone.
Yeah.
The ozone's interesting. A lot of people don't realize that it numbs the olfactory receptors in the nose. So after a few minutes of being exposed to ozone, they don't smell it anymore. So they're like, oh, my home smells better. Yeah, because they're not smelling like they were before they used it.
That's a good point, Steve. That's correct. Yeah.
So now we have a question here from Sean Gordon. Obviously, that's an interesting question at an event hosted by uHoo, where we are all users of uHoo. He's asking, what air quality monitors do you find most accurate and economical to purchase and use? So obviously we might be biased because we are all end users and fans of uHoo, but I don't know whether you guys have any comments on that.
So I do, if I might jump in. So recently we had our kitchen cabinets resurfaced. They took all the main panels and then they painted the rest, and they used their lowest VOC emitting product. Okay, well, it still stunk pretty good for about 6 hours before it cured. So I set up the uHoo, the Air Things, and the Phobot. And it was the uHoo that was best on the particulate levels and the ozone. It was more reactive than the other two. And that's what I found.
That's a great
The only
comparison.
thing that I can add is that we're trying to develop good equipment. We are using high quality sensors also produced by good companies around the world. And we're looking very carefully to the accuracy of every sensor. And I think that's why we have that high quality equipment also pay a lot of attention to our software and firmware. So perhaps that helps.
Yeah, so the message is you can trust in uHoo and be careful what you bring into your home, because if you want the cheap, you might get a problem with the accuracy of what you're actually measuring. So yeah, quality is very important when it comes to this, because we want to use the data for decision making and for improving and getting loads of ROI. And if you do it right, your ROI will be multiple times of your investment cost. And that is really what we need to target. And for that, I think it's very critical that we have a good strategy to make the data inform management about the optimized decision that we can take. As we have seen in the case of Steve's example, the ventilation there was the key, plus the janitorial services in terms of PM 2.5. And knowing that, understanding that, and then taking the action is critical to get your ROI. And we heard it as well from the UK examples from Nick, getting the right data, benchmarking, digesting the data, setting the right levels of notifications, of warnings. That is where the ability comes in to manage those things that we might have neglected in the past, but that we increasingly know either cost us a lot of money or make us a lot of money. We haven't focused today on electricity, but actually the electricity cost of an organization is maybe only between 5 to 10%, and then the rental as well. But the human resource cost of an organization, that's where the big money is. And if you look at IAQ, monitoring your IAQ, optimizing it, optimizing health and wellness, then you're getting good dollars in return, but only when you actually understand the linkage, measure it, and manage it. And for that, we recommend you to really enhance your IAQ data collation and actually the ability to understand what's going on, digest it, present it to senior management, and then take decisions. We have here from Anton, Steve and Nick, do you have any references of IAQ in restaurants, grocery, or supermarket settings? Restaurants, grocery, or supermarket settings.
Nick, you have anything there?
We have like a restaurant examples. I don't think we have grocery or supermarket.
Yeah, I used to as well, before the pandemic, take my uHoo device into restaurants and hotels, even in shops, and basically switch it on with my phone Wi-Fi, even in public transport. I mean, a bus with a CO2 level of 7,000 ppm and above, because there's no fresh air coming in, and it's loaded with people. Obviously, that would be a COVID transmission hotspot if it still were like that currently. Or even, restaurants where if there's no fresh air supply coming in, as the number of people builds up in the restaurant and the density increases, you can see the CO2 levels going up significantly. And sometimes as well, total VOCs, PM 2.5 could be coming from the kitchen, stuff like that. So yeah, there's different influencing factors there.
So we have found that in any of these situations where you have a lot of people gathered, that CO2 is the best indicator. So CO2, particulate, and TVOCs. And so in most cases, it's bringing in more outside air and dealing with or trying to balance that. In restaurants, it's a draft. In the grocery stores, we've got such a volume of air that it's hard to bring down the particulate levels that want to exist in the aisleways. And so when I look at these crowded places from an indoor air quality perspective before COVID, I wanted to wear a mask when I went into these places before the virus was there.
Yeah, I have as well a fascinating story, or maybe it's a sad story at the same time. So I stayed in a 5-star hotel and I switched on my uHoo at night. And I was like blown away that the CO2 level went to 2,500. And I confronted the chief engineer the next day because I knew him. This is like a very famous 5-star hotel. And I said, hey, bro, what's going on? At night, you know, have you guys switched off your fresh air supply? Oh, don't tell anyone. Nobody ever complained. Nobody knows. Yeah, we switch it off at night to save electricity because people want to sleep at night, right? High levels of CO2 is good for falling asleep faster. So those guys that switched it completely off during the day, there was no problem. And he told me, you're the first one ever in this hotel that pointed this out. Because if you don't measure, you don't know what's going on. So only with me having the data and seeing, hey, there's something wrong here, what's going on, I was able to identify the root cause of that unusual high CO2 level.
A study in Scandinavia has clearly shown that with these kind of levels above 2,500, it will affect your sleeping rhythm. So you get up in the morning, you have a headache, you thought, perhaps I've been drinking a little bit too much, but it's not the case. So you're also less productive. These are, it has been shown. Yeah.
So now I have a good excuse. If I ever have a hangover, which doesn't happen very often, because I'm not a heavy drinker, I can say to my wife, hey, darling, our CO2 must have been high last night.
Yeah, pure ventilation in the sleeping room. Yeah. But can you imagine when you have two people sleeping in the same room? Because then two people are producing, not only one. Yeah.
All right, great, excellent.
Okay,
that was good. Thanks, Steve, Nick, and Albert for this interesting chit chat. Anton thanks us for the helpful information and insights. Sometimes the informal chat is the most interesting chat. Thanks everyone for hanging around. We still have quite a lot of people actually on the call, despite us overstretching. So see you next month. We will look at decarbonization of buildings, ESG, and net carbon zero, an exciting subject. So see you again next month. And thanks everyone, and bye-bye.
Bye-bye.
Thank you. Thank you, everybody.